this is the gradient calculator. This thing here is our gradient calculator. In English, derivative means something which came from something else. So if you look at a laptop, it's actually a derivative from a desktop computer, because originally we had these desktop things. And then they evolved and a laptop came around. So a laptop was actually a derivative from a desktop computer. It came from a desktop computer. F dash of x is a derivative of f of x because it actually originally came from f of x. It got figured out from f of x. So this is the derivative. The derivative is the gradient. That's what it is. That's what it's there to find. So if you sub in 5 into the derivative, you're going to get the gradient at x equals 5, which in this case is about 0.5. If you subbed in -8, which would be about here, you can see the slope is about 1 or so here. So you'd get a value of 1. And if you subbed in -24, which is here, we can see the gradient here is 0, and this would give you 0. So this thing here actually is the gradient at different values of x. So here's an example. So we've got f of x equals this junk over here, and f dash of x is the gradient calculator. Now, I'm not going to show you how I figured this out right away, but it does actually equal this. So if we want to find out gradients of f of x, we actually use this thing here. And so if we want to find the gradient of f of x at x equals 1, well, we just sub in 1 into f dash of x. And so that's 6 times 1 minus 5. 6 minus 5 equals 1. So the gradient at x equals 1 would actually be 1. So the gradient is going to be something like that. And if we want the gradient of f of x at x equals -2, well, we do the same thing. We sub in -2, and it's 6x minus 5, so 6, -2 minus 5, which gives us -12 minus 5, which gives us -17. So the gradient would be -17, which would be something like that. Very steep, but negative. So hopefully this gives you an idea and sets you up for the rest of calculus. Good luck.